Okay, hi everyone. Welcome back to this video series on data centers, LAN port channels, known as the most medium to large scale Ethernet networks will typically have multiple links between switches because this provides redundancy and resiliency. Even so, we can also bundle these links to gain more bandwidth between switches. It's good to watch for when you've got an improperly configured multi-link switch network because you could very well end up with blocked ports. This is actually the result of STP just doing its job. In addition to that, routing protocols like OSPF and EIGRP will likely see all these redundant links as individual ones, which will only increase routing overhead. Cisco port channel to the rescue. Cisco port channel allows us to bundle up to 16 ports between switches, but some Nexus switches only allow 8 ports active between switches. The other 8 are just standby links. Sorry, now I'll just... Depending on your hardware and software, but I really don't think having 8, 10 gig or higher links between switches is anything to complain about. Figure 1212 shows us our network would look like if we had 4 connections between the switches before and after in configuring port channel. Okay, once your port channels are configured correctly, the Nexus switches can then load balance across all links by hashing the various header fields in a frame into a numerical value to select each link. These links operate via hardware-based load balancing. Important to note is that once your port channel is up and working, layer 2 STP and layer 3 routing protocols will treat those bundled links as a single one, which would stop STP from performing blocking. The result is that because the routing protocols now only see this as a single link, a single adjacency across the link can be formed. You can configure port channels as either layer 2 interfaces or layer 3 interfaces. And it's important to remember that when virtual devices, contexts, or VDCs are used, all ports in a port channel must be in the same VDC. If you do make the mistake of trying to configure ports from various VDCs together, your trunks would never come up between VDCs, meaning no worries. This is a mistake you're not likely to make twice. Another important factor you'll come across when trying to configure a port channel is that all ports you must use be configured identically. This is because the NX OS performs a compatibility check before adding ports to a port channel, and if the ports aren't configured identically, you'll get this error: command fail, port not compatible, port access VLAN. You can use force option to override the port's parameters, e.g. channel group X force. As the error output shows, one of the ports I tried to tweak was configured to be in an access VLAN, but it wasn't configured identically to the other ports. This can be overwritten with the force command, but it's always better to actually fix your issues instead of trying to force a port channel. Moreover, using the force command will not override any QoS mismatch configuration. So trying to get around that would fail regardless. You can configure port channels on a Nexus switch statically or dynamically via the Link Aggregation Control Protocol, LACP, which can bundle multiple links into a single port channel, as well as to help to detect link failures. LACP is a non-proprietary IEEE 802.1ax port channel negotiation standard. After enabling it globally on the device, you can then enable LACP for each channel by setting the channel mode for each interface on either active or passive. When a port is configured for passive mode, it'll respond to LACP packets it receives, but it won't initiate an LACP negotiation. When a port is configured for active mode, the port entity's negotiation with other ports by sending LACP packets, configuring and verifying port channels. Let's take a look at a simple example at configuring port channels and then verifying them. First, I'll go to global configuration mode and create a port channel interface. Then we'll add this port channel to the physical interface. I'll start with the interface port channel command and then apply the port channel to the interfaces with the channel group command. Let's take a look. Nexus 7K config interface port channel question mark 14096 port channel number. Notice that we can use the number up to 4096 on our port channel, but you can only create up to 256 across all VDCs. I'll just use port channel 1 for our example. Nexus 7K config if interface port channel 1, Nexus 7K config if int e3/3138, Nexus 7K config if range switch port, Nexus 7K config if range switch port mode trunk, Nexus 7K config if range channel group 1 CR forcefully add a port mode, specify channeling mode, Nexus 7K config if range channel group 1 mode question mark active, set channeling mode on active, on set channeling mode to on, passive set channeling mode to passive, Nexus 7K config if range channel group 1 mode on. You can use force option to override the port's parameters, e.g. channel group X force. Use show port channel compatibility parameters to get more information on failure. Nexus 7K config if range show port channel compatibility parameters port mode. Members must have the same port mode configured, either EF or auto. If they are configured in auto port mode, they have to negotiate E or F mode when trying to come up. If a member negotiates a different mode, it'll be suspended speed. As this output demonstrates, after I created the logical interface, I applied it to a group of interfaces. I want to ether channel using the channel group command. Cisco can and will use ether channel and port channel terms interchangeably. Notice that I chose to force the ports instead of spending time to make them all compatible. I decided to save some time and let NXOS do that for me, but I still made sure to verify the port's compatibility with the show port channel compatibility parameters command first, and I didn't skip the critical step before forcing. Okay, now after creating the interface port channel, I chose the mode I wanted to use. Don't forget that interfaces can be configured individually as active or passive, which allows the link to operate with LACP. If you choose the default mode, the port channel must be created statically without LACP. To verify the port channel, I'm going to use the show running config command plus the show interface command. Nexus 7K config if range sh run int port channel 1 command show running config interface port channel 1 time Thursday, February 28, 2025, 12/2013, version 613, interface port channel switch port mode trunk, Nexus 7K config if shint port channel 1 Port channel 1 is up, admin status up, hardware port channel address 0026982377C41 via F866F23E0FF1MTU. So look, I'm not going to read out the rest of this, but you can see it there anyway yourself. The command show running config provides the configuration for the logical port channel interfaces I'm using, and show interface port channel numbers tell me that the interface is up if it's working, down if it's not. The resulting output tells me all the ports that are members of this particular port channel. Last, the port channel summary provides a quick overview of the interface that are members of the configured port channels summary. This chapter was all about switching technologies with particular focus on spanning tree protocols, STP, and its evaluation to newer versions like STP and MSTP on their individual degree of compatibility with 802.1d. You also learned about the problems that can occur if you have multiple links between bridges, switches, and the solutions attained with STP. Finally, I covered configuring and monitoring of port channels with Cisco NXOS. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.